Hello students, here I am going to revise a chapter which is there for the first formative. The topic I have chosen over here is chemical kinetics. Mostly I will be doing the numericals, how to handle the numericals which is asked in subjective papers. So with regards to the first formative, we'll take this first question. Okay, this is the question. So question asked over here is which of the following expression is correct for the rate of the reaction given below. So this is what the equation is given. This is the equation. These are the reactants and these are the products given over here. Let's write this. See, before we solve this, if I ask you, if there is a reaction like this, 2A plus 3B giving you something 4. See how you are going to write a rate equation for this. You will be writing this way. Rate will be is equal to, you are equating minus 1 by 2 change in concentration of A by delta T. You are writing this stoichiometric coefficient down, and this minus sign because it is the reactant, you are writing for the reactant. This minus over here again delta B, delta represents change in concentration of B in given time delta T divided by 3, right? Which is also is equal to 1 by 4 delta C by delta T. This is how you are going to write a rate equation. Similar is the question. This is the similar question which is asked over here, and let's do it. So first we'll write a rate equation for this. We'll write a rate equation for this way. Rate will be is equal to I'll use this color, red color. Rate will be is equal to minus 1 by 5 minus 1 by 5 change in concentration of Br minus by delta T. Also, which will be is equal to, I can write rate is equal to minus change in concentration of Br O3 minus by delta T. Also, it could be written as minus 1 by 6 change in concentration of H plus by delta T. Also, it could be written in terms of product, it could be written as 1 by 3 delta H2O by delta T. Also, sorry, yes, of course, this is first I'll write Br2. This is Br2, and this is equal to 1 by 3 delta H2O by delta T. Delta represents a change in concentration. This is what the equation, rate equation we will be having, but we don't require a whole equation. In the options, if you see, there are Br minus and a H plus that is related. So we'll relate this. If I relate these two terms, Br and the H plus, right? It is like writing A is equal to B, B is equal to C, C is equal to D. So C is equal to D. So I can relate any of this. A is equal to C, B is equal to D. So it is this way. So I can relate all these terms, and I'll write over here minus 1 by 5 delta Br minus by delta T, which will be is equal to minus 1 by 6 delta H plus by delta T. This minus and the minus, it will become plus, right? Or we can say that you can get this minus sign over here. It will become positive quantity, right? So it is as good as writing, it is as good as writing later 1 by 5 delta Br minus by delta T, which is equal to 1 by 6 delta H plus by delta T. So which of the option is correct from this? So they have shown Br5 minus, uh, if I get this over here, if I get this phi over here, so delta Br minus by delta T, which is equal to 5 by 6. This 5 will go over here, delta H plus delta T. So this is what is asked. And one of the option which is getting related over here is this. This is the option. This is the answer for that question. So let's go for the next question. So here is the next question. We'll solve this. It is a fill in the blanks. The average rate and the instantaneous rate of the reaction are equal when two rates have the time interval equal to 0, and at the beginning of the reaction, in the middle of the reaction, at the end of the reaction. Many options are given. I'll give a simple idea. Simple idea is that if there is a reaction this way, 3A plus 2B giving you 4C, right? How you are going to write the average rate for this? Average rate, there are two things. Average rate, the one which we have done in the first question. That is what the average rate we have taken. So minus 1 by 3 delta A by delta T. Okay, this is also is equal to minus 1 by 2 delta B by delta T. And this will be is equal to 1 by 4 uh, delta C by delta T. So how you'll write an instantaneous rate? Instantaneous rate is written 1 by 3, same manner, but instead of delta there will be D. I'll tell you the significance of this, dA by dt. So this is 1 by 2 d by dt, and this is 1 by 4 d c by dt, right? So when this delta changes to dt, see, when delta t is tending to 0, it is not 0, it is very 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 close to 0. When delta is tending to 0, it is written as dt, and dA is written as what? This delta is written as dA, right? That's what the difference. So answer for this is that when two rate have a time interval equal to 0, means it is almost 0, means it is tending to 0. It has not become 0. Very close value to 0. So the answer correct is option A over here. Okay, here is the next question. Okay. So question ask, sorry, not this. 1 minute. Yes. Question is rate law for the reaction, for the following reaction, for this reaction. This is the reaction. Rate law is given as rate is equal to K A raised to B. If the concentration of B is double, then rate of reaction will become what? So reaction I'll write first separately. This is A plus 2B. What you get is AB2. This is the product what you are getting, right? Now, rate of the reaction, rate expression from the rate law expression is given is this K A B raised to 2, right? When the concentration of B is double, then rate of the reaction will be what? Let's say this is rate 1. Okay. Now, if you change the concentration of any one of the reactant, what will happen? The rate will change. So I'll change the concentration and I will call that to be a rate 2. Now, rate constant is not something which is going to change with concentration. It can be changed by temperature, right? So temperature is not changing over here. So A, what they have said, concentration of B is doubled. So I'll keep this as A, and concentration of B I am making double, means instead of B I am writing 2B, the whole square. So what would be this? Rate 2 will be is equal to K A, and you take this 2 out, then it will be what? 2 the whole square, and this square bracket B the whole square. So 2 whole square becomes 4 times this K A, and this is B the whole square. So rate 2, which is written over here, is equal to rate 2 will be is equal to 4 times. What is this value is equal to? It is equal to rate 1. It can relate K8 and B raised to 2 is equal to rate 1. So it is 4 times of the rate 1. So increases by 4 times, decreases by 2 times, increases by 2 times, or remains the same. So answer is increases by 4 times. Answer A is correct for this. Okay, here is the next question. Um, let's solve this. Ammonia and oxygen reacts at high temperature as per this reaction. The reaction is given as 4 moles of ammonia reacts with 5 moles of O2, forming 4 mole of NO, right? And plus 6 moles of H2O. Yes. So, this is a reaction. In an experiment, rate of formation of NO is 3.6 into 10 raised to minus 3 moles per liter per second. Calculate rate of disappearance of the ammonia and second rate of formation of water. So first I'll define all the term. First we'll write a rate equation. How you are going to write a rate equation? You can give a try. You can pause this video for some time and you can give a try how you will write a rate equation. Then you can check. Yes. So here I'll write a rate equation. So rate equation is equal to minus 1 by 4 delta change in concentration. Average rate I am writing. This is by delta T, which is equal to minus 1 by 5. Change in concentration of O2 by delta T, which is also is equal to 1 by 4 delta NO. You take average rate, instantaneous rate, doesn't matter. Okay, it is one and same. Here it is, in this problem, it doesn't matter. Okay, so delta H2O. Check your answer if you have written this. Yes. So this is what the thing is. Now understand this whole quantity, I will just put a bracket for this. This whole quantity represents a rate of the reaction. This whole quantity represents rate of the reaction, rate of reaction, along with stoichiometric coefficients. Okay, so this is one thing. Again, this full bracketed term represents rate of the reaction. This also represents rate of reaction. Also, whole bracket, like including a stoichiometric equation, this also represents rate of reaction. Also, this quantity whole, including those denominators, okay, where we have written this stoichiometric coefficient, that also, like including that, it represents rate of reaction. Rate of reaction. Understand the difference between rate of reaction and rate of appearance of something and rate of disappearance of the something. So, I'll rewrite this. I'll rewrite this. Since what is given is in an experiment, rate of formation. What does this mean? Rate of formation means what is the thing? So NO, we have the data regarding a NO, something we are having. So I can I relate this? I will write rate is equal to this. So first I will write rate is equal to this. First I will write, oh, what is this? First I will write rate is equal to, I'll equate it to this since I am having a data regarding 1 by of NO. So whole this term defines a rate of the reaction. Okay, but only this term. Okay, if I want to separate, then only this bracketed term, excluding that 1 by 4. This will represent rate of rate of appearance of NO. Okay, same way I can relate rate is equal to minus 1 by 4 delta NH3 by delta T. So excluding this 1 by 4 over here, okay, uh, I can write this rate is equal to rate, since there is a minus sign. What I do is I will take this out and I'll write inside minus delta NH3 by delta T. Right? This is what I'm going to write. So this quantity represents rate of rate of disappearance of NH3. And along with this 1 by 4, it is telling you about the rate of the reaction. See, while writing the definition in NCRT, the rate definition of the rate is given this way. Rate is a decrease in a concentration of any one of the product or increase in concentration of any one of the reactant in given time, right? So that is what the rate definition. So here I am not including. So they have mentioned about rate of formation of NO, means what quantity they have mentioned? They have mentioned only delta NO by delta T. Okay, and the first question over here is rate of disappearance of the ammonia is asked. So I'll clean this. This was for your understanding. So I'll clean this part. Okay, if any doubt you are having, you can just comment over here on the YouTube only. I'll get in contact with you. You can just mention me your number also, phone number, or you can just stay connected through WhatsApp also. I will share my personal number over here if you are having any difficulties regarding that. Mm, here, what I shall do over here is okay. Rate of disappearance of ammonia means I have this data and I am told to find this. So I will equate these two quantities. What I'll equate. So the rate of appearance, rate of disappearance, this is clear. So I will equate these two quantities over here. So I'll write this minus 1 by 4 delta NH3 by delta T is equal to 1 by 4 delta NO by delta T, right? So here, what is asked? Rate of disappearance of ammonia. Now you decide how you are going to write a rate of disappearance. Means you have to take this 1 by 4 outside and this minus sign and delta NH3 by delta T is equal to 1 by 4 and delta NO by delta T, right? What is given? This bracketed term, okay, this curve bracketed term is given. So from this equation, this 4 and this 4 will get cancelled. What remains is what remains is this minus delta NH3 by delta T. See this minus sign you don't have to take anywhere because along with this minus sign it defines rate of disappearance of ammonia. What is remaining? Rate of appearance of the NO was given directly, it is equal to 3.6. No, so I'll just substitute this bracketed term is rate of a formation of NO, which is given. Rate of formation of NO is given to be 3.6 into 10 raised to minus 3 moles per liter per second. This is what was given. So this minus sign, don't worry, don't take this minus sign anywhere because this together is not a negative quantity. Remember this minus sign and this difference, right? This difference together it is positive quantity. How? I'll teach you this. Take simple example. Take simple example A plus 2B giving you 3C. Okay, I'll show this on another page because my window will come over here. So I'll show you this why that is not negative. So 2a plus 3b is equal to c, right? So why that we are going to write this to be rate is equal to how you are going to write a rate equation for this. Rate equation could be written as minus 1 by 2 delta a by delta t equal to minus 1 by 3 delta B by delta T. Also, I can write delta C by delta T. This I am going to write. Now, why this quantity is not negative? Speed of the reaction cannot be negative because this minus sign and this difference is negative. Together it is positive. Let's understand this. This initially at time t is equal to 0 when reaction is not started. Okay, let's consider the concentration of A to be something. I'll consider this is to be something 5 and a concentration of this I'll consider something to be 10, and this concentration at time 2 is t is equal to 0 means this concentration is 0 means reaction has not started, there is no any formation of the product, right? So let's say this after 10 minutes this reaction may be taking 1 hour or half an hour for the completion, but let's understand what will be the thing after time 10 minutes. After 10 minutes, now what would be a concentration of the reactant A? Obviously that concentration of the reactant A will be less than 5 because reactant is getting consumed, so it won't be more than 5, obviously it will be less than 5. Let's say it has gone down to something 3, and this concentration has gone down to something 7. Okay, and this has raised by something 3 amount. Okay, so how this is 3, that will vary from the reaction to reaction. What is our point? We have to understand that concentration of reactant has gone down and that of the product has increased, right? This is what is the main understanding we have to take from this data, right? This is just example I have taken for you to make the significance of this negative sign, right? So what is this delta A? Delta A is what? Delta A is concentration of A final minus concentration of A initial. So what is final? This is something final, right? This is after 10 minutes. That is final. So this is 3 minus 5, which is going to come to be minus 2. So minus 2 means over here delta value in this example is minus 2. So minus 2 into this minus is what? Plus. So together this quantity is positive. Now think for the product side. We don't put any negative sign, but we keep that as a positive only. Why? Delta C, if you want to find a delta C, it will be what? Concentration of C final minus concentration of C initial, right? So concentration of C final is how much? Concentration of C final is 3, initial is 0. So this itself is a positive quantity. We don't require a negative sign. Yes, this is done. So we'll take a second part of this question. Second part of this question is rate of formation of water is asked. Rate of formation of water, again, you are going to relate it this way. Um, you are going to take this. I'll solve here only. Yes, rate of formation of water is asked. We have the equation. So I will relate either this or this versus this. I can do anything for that matter. Uh, so rate of formation of NO is going. So I'm going to relate this 1 by 4 delta change in concentration of NO by delta T is equal to 1 by 6 delta H2O by delta T. So what is our rate of formation? Means this term, this 6 will go over here. So therefore, delta H2O by delta T will be is equal to 6 by 4 delta NO by delta T. So this value is given, right? Delta NO by delta T is a rate of disappearance of the NO. So what would be the answer? 6 by 4 into uh, 3.6 into 10 raised to minus 3 unit will be moles per liter per second. So this will be 0.94 into 9, 0.9. So 3.6 will be like 0.9 into 6 will be how much? 5.4 into 10 raised to minus 3 moles per liter per second will be the answer. Rate of formation of water. So this is also solved. Yes. Let's solve this next question. Oh, rate of gaseous reactions become half when volume of the vessel is double. What is the order of the reaction? Okay, so we'll form one equation. Okay, there is one reaction. Rate is getting converted, reactant is getting converted to product. Okay, this is the simplest thing we can write for the rate. So how, or we'll write this to be A. We'll write this reactant A getting converted to product P. Let's not worry about the stoichiometric coefficient. So I am going to write rate equation as a rate is equal to K is a rate constant, concentration of A raised to X, X. Okay, and this X is what? X is a order of the reaction which I need to find. Order of reaction. So here rate of the gaseous reaction become half, rate of gaseous reaction become half when volume of the vessel is doubled. What is the order of the reaction? So let's write this to be is equal to rate 1. I'll write this to be rate 1, and this is a concentration of the A. Now they have mentioned that when volume of the vessel is double, when the volume of the vessel is double, what will happen to the concentration? Concentration will become half. Let's take this simple example. Um, let's say this is 2 liter. This is 2 liter of the volume, and 2 liter of the volume, and these are the particles of the gas. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So this is the particles in this certain less volume. So here it is a 2 liter. Now what you do, now you increase the volume. Now you are increasing the volume. You are transferring it to some other container where the volume is not 2 liter, it is 4 liter. Okay, 4 liter. Now same 15 particle. Yes, same 15 particles. So where you see the more density, here you see the more concentration, here you see the less concentration. As you keep on increasing the volume, concentration is going to decrease. So here volume of the vessel is doubled. So what will happen to the concentration? Concentration will become half. So it will give rise to new rate, that is rate 2 I will say, and rate constant is not going to change, but this concentration is going to become half raised to x I am writing, because we don't know this order. So this is equation 1 and this is equation 2. So what do we understand from this is that if I divide equation 1 by 2, dividing equation 1 by 2. So what I do is I'll do it here only. I'm dividing 1 by 2. So what will happen? Okay, rate. Okay, I'll write this again because there is something change. Rate 2. The rate of reaction become half when volume of the vessel is doubled. So this is the concentration that will become half, right? That concentration will become half when volume of the vessel is doubled like this. So here, so rate 2 will be what? Half of the first one. Means rate equation 2 will be this way. Equation 1, if I write rate 1 is equal to k a raised to x. So equation 2 will be rate 1 by 2, because it is said the rate becomes half when volume is doubled. So A is becoming half. Volume is double means A is becoming half. Now you divide both these equation. So this rate 1 and rate 1 will get cancelled. This K and K will get cancelled. So what will remain over here is 1 by 2 equal to, this is A raised to x, and this is A by 2 raised to x. So this could be written as 2. This could be written as 2, and this further could be written as, since powers are same, a divided by a by 2 raised to x. So this a and this a will get cancelled. What remains is 2 is equal to 1 by 2 raised to 1 by 1 by 2. Yes, 1 upon 1 by 2 raised to x. So 2 is equal to 2 is equal to 2 raised to x. So what is this? Base is same, so therefore x is equal to what? 1. So this order of the reaction will be is equal to 1, right? So here also I'll tell you how it is 1. We are getting this, no, 2 raised to 1 and 2 raised to x. You take log on both sides. So log of 2 raised to 1 will be is equal to what? Log of 2 raised to x. So from the identities of the logarithm, this could be written as 1 multiplied by log of 2, which is equal to x multiplied by log of 2. Log 2 will get cancelled. Therefore, x will be is equal to 1. That's it. Okay, here is the next question. Let's solve this. Question asked is in a reaction to x changing to y, the concentration of decreases, x decreases from 3.0 molar, that is, it is written this way, no? 3.0 molar. Capital M means it is as good as it is same as writing moles per liter. Means here M represents a molarity. Molarity. Okay. To 1.5 molar in 4 minutes. Means 3 was the initial concentration. It has changed to 1.5 in a 4 minutes. So what will be the rate of the reaction? So this is the reaction 3x changing, sorry, not 3x. It is 2x changing to y, right? So how you will write a rate of the reaction? Rate expression, average rate, delta. Rate is equal to minus 1 by 2 change in concentration of the x by delta t, which is equal to change in concentration of the y upon delta t. Time is a delta t is a time difference. Now what is delta x? We'll relate only this because we know the change in concentration of the x. So I will only solve, I will relate this case. So let's find delta x. What is delta x? Delta x is concentration of the x final minus concentration of the x initial. So what is delta final? It becomes decreases from 3.0, means in this case 2x plus y at time t is equal to 0. The initial concentration was 3.0. Okay, initial concentration of this x was 3 molar or 3.0 molar. After a time of 4 minutes, 4 minute, it changes to 1.5 molar, right? So this is final is 1.5 minus 3. So this is minus 1.5, right? So in this formula, I am going to substitute it. Therefore, rate is equal to minus 1 by 2. And this delta t is what? Delta x is what? Minus 1 by 2. And what is this delta t? Time difference is of 4 minutes. So this is 4. So rate will be is equal to minus into minus plus. So 1.5 divided by 8, right? So how you are going to solve this? 1 by 8 is going to be written as 15 by 8 into 10 raised to minus 1. Now it will be very easy to solve, no? So never get scared, when such type of things happens. You can always uh, make this kind of number by using the powers. So 8 by 5 is 8 ones are 8. Then this is 8 eights are 64, right? That is what happens. 1.8 approximately 1.88 we can write. So answer is this. And unit will be moles per liter per second. So here a slight mistake is there. What I've made over here is 1.88 mole. It is, I did not consider this 10 raised to minus 1. So it will be answer um, 0.188 and units will be not moles per liter per second. It is moles per liter per minute because we took the time in minute only, no? Directly I took that to be 4. If you wanted to the answer to be in second, you multiply it by 60, where delta t means in denominator you will be multiplying by 60. Means if I divide this by 60, 1 divided by 60, then answer will be moles per liter per second. Means this 0. Answer will be 0.188 divided by 60. Means answer in moles per liter per second. This is written as 0.003133 moles per liter per second. Further, you can write this way to look nice 3.133 into 10 raised to minus 3 moles per liter per second. You want and see. So next question will take. Let's take this question. A first order reaction is 20% complete in 10 minutes and calculate time required for the 75% completion of the reaction. So let's first go with the formula. So what you are told to find? Calculate the time. You have to find a time. So what is a rate law, integrated rate law expression in terms of time for a first order reaction? Time is equal to 2.303 upon K log of R0 by R. Okay. So this R0 is initial concentration, concentration, initial concentration of reactant at zero time or when the reaction has just started. And this is concentration of reactant after time t, after time t, maybe 2 minutes, 3 minutes, or anything after the reaction has proceeded. So this is the formula. We have the initial concentration, say 75 percentage means um, if we are taking R0 to be 100, if we are taking R0 to be 100 means maximum concentration. Let's take this to be 100. Okay, this is the simplest way. So what will be a concentration of the reactant left? Okay, 75% complete means it is 100 minus 75, right? So R0 will be, R will be 100 minus 75%. So this will be 25. R will be 25. So we have the R0 and we have R, but what we don't have is K. So let's find K first. To find K, we are going to use a same equation. We are going to use the same equation, but in terms of K, I will write K is equal to 2.303 upon time log of R0 by R. And first statement, what it is making, it is a first order reaction. A first order reaction takes a 20%, reaction is 20% complete in 10 minutes. Calculate the time required for 75%. So using the first data, I will find the K. So therefore, K is equal to 2.303 and time is 10 minutes. So can I write this in let's keep this in minute only. Time I'll take in minute only. So what is R0? R0 will take always to be 100. This is one way. You may be having a different method also, taking 100% like 100x you may consider or 1x that you will consider. So this is initial. I'm taking 100. This is the simplest way I'm telling you. And 20% complete. 20% complete means how much is remaining? R will be, if I consider for the first condition, this is for the second condition. For the first condition, um, if R0 is 100, then R will be is equal to what? 100 minus 75, no? Sorry, 100 minus 20, right? So 20 is completed. So what is left? 80% is left. That is what the concentration of reactant left. So that's why I will write this to be 80. That's it. So this is 2.303 upon 10, and this is log of uh, 10. This 10 and 10 will get cancelled. 10 by 8. We don't have to get like, okay, how to use logarithm table, where to use logarithm table, we have to search for the logarithm, or how to find the log of 10. 10 by 8. See, I'll solve this separately so that I don't have to write this again. Log of 10 by 8, how to solve? I'll tell you a simplest method. Log of 10 by 8. How to solve this? See, log of 10 by 8 is written as log of 10 from the identities. Log of 10 minus log of 8. Okay, log of 10 minus log of 8. So uh, I'll further simplify this. Log of 10, log of 8 could be written as log of 2 raised to 3. See how what I am doing. So this is written as a log of 10 minus 3 multiplied by log of 2. See, log of 10 is very easy to find. Log of 10 is 1 minus 3 into what is log of 2? Log of 2 is 0.3010. So what is this? 1 minus 0.9030. So answer for this will be is equal to 0.097. This will be answer. So I'll substitute it over here. Okay. So we'll do this. This is 2.303 upon 10 multiplied by 0.097. So multiplied by 2.303 and divided by 10. So answer comes to 0.02239. We'll round it off to 0.2234. Unit will be per minute. So we found out K. We found out K. Now job is we have to substitute over here. So I'll clean this. So now in the second condition, I'm finding a time. See, the case K is not going to change. K we found out to be is equal to uh, 0.22, 0.022, 0.2234. Right? This is what K we found out. So let's find a time, that is calculate time for 75% of the completion reaction. T is equal to 2.303. K is 0.02234 into log of R0. I'll consider this to be 100 divided by R is 75% completed. So R0 is 100. So here 75 means what? This is 100 and R will be is equal to 100 minus 75. That is what is left. So which is equal to 25. So this is 25. So this is time will be is equal to 2.303 and this is 0.02234 and this is log of 25 4 times. So log of 4. Now again, you don't require a log of 4, right? We can directly do it this way. 2.303 divided by 0.02234 into log of 4 could be written as log of 2 raised to 2, right? So here this is 2.303. This chair is going down again and again, That's why I'm also going down after some time. Uh, 0.02234 into 2 into log 2, right? From the logarithmic identities, it is this way. Log of 2, very easy, सगळ्यांक खबर आसतलो लॉग ऑफ टू कसो आसता. लॉग ऑफ टू इज रिमेंबर दिस याद धरपाचो व्हॅल्यू हो खूप कडेन यूज जाता. ओके लॉग ऑफ टू इज वॉट 0.3010 सतत याद धरा व्हॅल्यू लॉग ऑफ टू. सो इफ यू नो द लॉग ऑफ टू तुम्ही लॉग ऑफ 4 फाइंड करूंक शकता, लॉग ऑफ 8 फाइंड करूंक शकता, लॉग ऑफ 16 फाइंड करूंक शकता. ओके सो आय जस्ट क्विकली सॉल्व दिस एंड आय गेट द आन्सर. सो 2.303 multiplied by 2 multiplied by 0.3010 is equal to this divided by 0.02234. Answer is time is equal to 62.09 minutes because this unit was in per minute. These units are going to get cancelled. So final units will be in minutes. That's it. Uh, this question. Calculate the overall order of the reaction which has the rate expression as this. See, order is what by definition? Order. Sometimes the definition of the order is also asked. It is sum of the powers in which sum of the powers uh, in rate law expression, sum of the powers uh, definition is sum of the powers uh, of concentration, sum of the powers of concentration in rate law expression. This is what the meaning of the order of the reaction. So rate law is given this way. For this, rate is equal to a raised to 1 by 2 and b raised to 3 by 2. सामके simple problem. असले question विचारले you shouldn't be losing marks. Okay. See what is the sum of this? Half plus 3 by 2. So order over here, order n is half plus 3 by 2. So this is what? 4 by 2. So which is equal to 2. So this is second order reaction. We can find this very easily. Okay, let's take this question. Question asks is the rate constant of a first order reaction is 60 per second. Okay, how much time will it take to reduce the concentration of reactant to 1/16th? See, this question which is written over here, they have asked one is 1/16th. Other possibility that this question could be modified is that like calculate 1/16, how much time will take to or the question could be like calculate 1/16th life, or let's do that question later. First, we'll understand what is this question is. So you are told to find a rate constant is given, right? Time, right? To reduce the concentration of reactant to 1/16. So I will write the reaction. We'll use different color. मातशे color वेगळे वेगळे use केले की बरे दिसता. Same black and white बरे दिसना. So 2.303 upon k and log of r0 by r. Okay. Now, what is R? The K is given. K is given to be is equal to 60 per second, right? And what is R0? Let's consider that R0 is X. So, what would be reactant? Uh, how much time will it take to reduce the concentration of reactant to 1/16? Okay, means this is now concentration is 1/16th of the X. That is 1/16th of the X, right? So therefore, what you are going to do substitution, how you are going to do the substitution over here? It is this way. So time required will be is equal to 2.303 upon 60 multiplied by log of r is x upon 1 by 16. This x and this x will get cancelled. So therefore, t is equal to what? T is equal to 2.303 and this is 60 and this will become log of 16 now. This log of 16. Okay. So log of 16 is 2.303 Log of 16 is not 2.303. I'm just writing. Log of 16 is what? This could be written. See, we know the log of 2. So this could be written as 2 raised to 3. 2 raised to 4, right? 2 raised to 4 is 16, no? So 2 into 2 into 2 into 2. 2 into 2, 4. 4 into 2, 8. 4 into 2 is 16. So this number 16 could be written as this way. So this is 2.303, or you can directly find a logarithm of the 16 using logarithm table. No issue. You will get the same answer. This is over here 60. So this is written as 4 into log of 2. So this is 2.303 divided by 60 into 4 multiplied by 0.3010. So this is here. So final answer will be 2.303 multiplied by 4 multiplied by 0.3010 divided by 60. So answer is 0.046 per second will be a time. Sorry, time is asked, no? So it is just second, right? This much time it will take, this much time it's going to take to reduce it to 1/16. Okay, 2.303. One more time we'll do this. 4 multiplied by 0.3010 divided by 60. Yes, this unit is second. Now, same question, they can ask you in this format. See, what we have done, we have considered 1/16th, right? So same question I will slightly modify. Same question I will slightly modify and okay, see the modification. So many students make mistake over here. Uh, how much time it will take to reduce the concentration of reactant to 1/16th? This statement I am changing to this. Calculate, calculate 1/16th life. Like we say half life, here I am saying 1/16th life. So that time what you are going to write is that time. What is half life definition? If we go by half life definition, it is a time at which concentration of reactant is reduced to half of its initial concentration, means 1 minus half, no? So 1/16th will be what? Life. It is 1 minus 1/16, or we can do this way. If it is 100, then it is 100 upon 16, right? This relation. So that is what the 1/16th life will be, right? So here I will write this to be t is equal to 2.303 by k. This is just an extension. If there is any confusion, then it is this way. So it is r0 by r. So what is r0? Let's say r0 is maximum. I'm taking that to be is equal to 100. Okay, you can take 1 also. No issue. So it will be 1/16th of that. So what will be a r? R will be is equal to 100 minus 100 upon 1/16, right? 100 into 1/16. So this is 100 minus 100 upon 16. So what would be that answer? 100 into 16 minus 100 upon 16. So this is you take, this will be 15 upon 16 into 100, right? I'm just finding r over here. So it is 15 upon 16 into 100, right? It is 15 multiplied by. So here r will be 93, 93.75. This is what the r we found out, right? I substitute it over here. Yes, no? So we'll do it over here. We'll substitute r value, whatever we got. 2.303, and this is 60, and log of R0 is I'm taking this to be 100 divided by 93.75. So this, so you are going to proceed this way: 2.303 upon 60 into log of log of this answer is 1.06. Very negligible time you are going to get. Find a log of 1.06. That will be very, very less. Multiplied by that, this answer will be very, very negligible. Time required is so. I wanted to explain the concept, when to use what and how to do this. Hope this is Okay, we'll start with this question. Question ask is rate of reaction is 2 of a 2a plus b, and this is the reaction given over here. For this rate of reaction, for this reaction, rate law is given as this. This is a rate law which is given with rate constant equal to zero point 0.5 per mole liter per second. Right? This unit says that it is a second order reaction, and also from the rate law I can understand that it is second order. Right? Calculate the rate of reaction when this and this is the concentration. Second, when concentration of A and B have been reduced. So first we'll solve this question. First we'll take this question. First one. So from the rate law expression, what we can understand is that we'll write this rate is K A raised to 2. Means here the rate is dependent, we can say that it is dependent on second order of the A. Means here rate is directly proportional to the concentration of the reactant A, and it is not dependent on concentration of the B. This what we are getting, no, or this is something which is supplied. This is experimental. You cannot figure out this just by looking at a chemical reaction, unless and until it is told that this reaction is one step reaction. One step reaction you can easily tell, but just by looking at a reaction also you cannot tell that whether it is a one step reaction or a two step reaction. So calculate a rate constant for the reaction, right? Calculate a rate of the reaction. Yes. So what they are saying is that one, when A is 0.60 and B is 0.05, so whatever may be the concentration, so this on this rate is not dependent. So rate is equal to K is given to be 0.5 per mole liter per second. And what is the concentration of the A? It is 0.6 the whole square. So this is 0.5 into 0.6 multiplied by 0.6. So it is this simple. Uh, so 0.5 multiplied by 0.6 multiplied by 0.6, right? So this answer is 0.18. What would be units for this? Units should be moles per liter per second. Remember, whether it is first order, second order, zero order, unit of rate is never going to change. It is always moles per liter per second. Unit of rate constant that is going to vary. Remember this. So here how we are getting this moles per liter per second. So unit of 0.5 which is written over here is how much? Let's understand the unit of rate. So unit of 0.5 is per mole liter per second. Unit of this is moles. Concentration is moles per liter, the whole square. So here per mole liter per second, and this is what mole raised to 2 and liter raised to minus 2. So what will happen is that this will be mole raised to 2 minus 1, liter raised to minus 2 plus 1, and this is per second. So what remains over here? Mole raised to 1, liter raised to minus 1, and per second. So what is this? Moles per liter per second. Okay, so this is the answer. So second question, when the concentration of A and B have been reduced to one fourth. So let's say that initial rate 1 is this K A raised to 2. So rate 2 will be what? Rate 2 will be what? It will obviously change if we are reducing the concentration of A and B to one fourth. So here what will matter is the concentration of A only. From the rate law expression I can understand. So one fourth of A. One fourth of A the whole square. So this could be written as 1/16 of K, and this is A the whole square. This is new rate, right? Since the concentration has reduced. So 1/16 because it was square. So rate 2 is 1/16, and what is this is equal to rate 1. So it is equal to rate 1. So 1/16th value. Calculate rate of reaction is 1/16th of the rate 1. Yes, it is this. So next question. A first order reaction is half completed in 3 minutes. How long does it take for the completion of 99% of the reaction? Means will this is the question. Means time is asked, right? Here time is asked. So time is equal to what? Time is equal to 2.303 upon k log of r0 by r, right? So r0 I know, right? R0 I know how much it is. Initial will take 100. And what is R? R is 99% completion, means how much is remaining? 100 minus 99 means R is equal to 1. But we don't have a K, right? We don't have a K. So how to find that K, right? So to find K, then only I can find the time. To find K, it mentions that first order reaction is half completed in 3 minutes, means T half. It is telling about a T half. T half is what? 0.693 upon K. This is for the first order reaction. This T half is for the first order reaction. So here T half is equal to how much? T half is 0. So 0. K will be is equal to what? K will be is equal to 0.693 upon T half. T half is how much? 0.693 upon 3 minutes it is given, right? So therefore K will be is equal to, therefore K will be is equal to 0.3, 0.231, right? 231 after dividing this. So we got this K value. Now just substitute over here. So therefore time is equal to 2.303 upon 0.231. Can you guess what is the unit for this? Unit for this is per minute, because it is given in minute, no, per minute. So time also will be getting in minute. So always identify, if in the question it is mentioned give the time in minute, second, accordingly you have to change the units of this. So log of what is r0, it is 100 divided by what is concentration left, 1, no. So this is 2.303, this is 0.231, and multiplied by log of 100. Log of 100 is 2. Log of 100 is 2. Characteristics is 2, no? And 10 under 0 is 0. You will get this way on logarithm table. So 2.303 multiplied by 2 divided by 0.231. So answer is time is 19.94 minutes. Okay, this is the simplest topic you can have for the exam in the whole syllabus. Next question. This is based on a activation energy. This question is based on a activation energy. So question is rate of particular reaction triples when temperature changes from a 50 degree to a 70-degree Celsius. Calculate the activation energy. Calculate the activation energy of the reaction. Calculate the activation energy of the reaction. So what is that formula? I'll just give you a brief idea, how do we do this, or we'll write the formula. It is formula is this log of K2 upon K1 EA upon 2.303 R, and this is 1 upon what would be this? T1 minus 1 upon T2. Okay, and understand that T1 is smaller than T2. Now, if you are getting confused between whether it is 1 by T2 minus 1 by T1, then remember that this should be smaller. Understand, if this is bigger, then whole value will be smaller. and smaller minus bigger is negative value. We don't want negatives over here, right? So this is the thing. So calculate the activation energy. We need to find the EA. What they have said is that rate of a particular reaction triples when temperature changes from this. So we are having different T1 and T2. So T1 is what? It is compulsorily we have to change a degree Celsius to Kelvin. T1 is 50 degrees Celsius, which is equal to 273.15 plus 50, right? So this will be 323.15 Kelvin. And T2 is what? 70 degrees Celsius. 273.15 plus 70 means 343. 343.15 Kelvin. So we got this both the values of the temperature. What value R you are going to take? R will be 8.314 joules per Kelvin per mole, right? A is joules per mole. Now what is K2? Actual values are not given, but rate triples. So K2 is two times. If K1 is if K1 is X, then K2 is what? It triples, no? So 3 times X, right? So we'll substitute in this formula all the values. So here, therefore, log of 3x upon x is equal to EA. This is what we need to find. This is 2.303 into R is 8.314, 8.314. And this is 1 upon 323 only I'll take for the simplicity, and this is 1 upon 343, right? So this x and x will get cancelled. What remains is log of 3. This is EA 2.303 and 8.314 in bracket 323, 343, and this will be 343 minus 323. So log of 3 is 0.4771. This is EA upon 2.303. Hope it's coming into the frame. Yeah, I'll take this up. EA upon 8.314 into this will become 20. This is the difference. This is 323 and this is 343. Now what is EA? EA, just rearrange. EA will be 0.4771 multiplied by 2.303 multiplied by 8.314 multiplied by 323 multiplied by 343 divided by 20, right? So rest part is multiplication. You know it well. So 0.4, I'll just use calculator, 4771 multiplied by 2.303 multiplied by 8.314 multiplied by 323 multiplied by 343 divided by 20. So answer what I am getting is activation energy to be is equal to 50603 0.43 joules per mole. How? Let's check the unit also. Let's check the unit over here. I'll use this space. You can take the screenshot or hope you are noting all this down. So let's check the unit of the EA. What will be the unit of the EA? What is the unit of this 0.4771? It is just value, so no unit, right? 2.303, no unit. 8.314 is joules per Kelvin per mole. What is this? Kelvin and Kelvin. So here two temperatures are there, Kelvin and other is also Kelvin. Everything is multiplied. This multiplied will be there. Dot. And this is also Kelvin. So this Kelvin and this Kelvin per Kelvin and Kelvin will get cancelled. What remains is joules per mole. So unit is joules per mole. So this could be written as right. This could be written as 50.603 into 10 raised to 3, not 10 raised to 3, kilojoules per mole. So this would be answer. Can have a look like this. So here is the question. Next question. A first order rate constant for the decomposition of this reaction at 600 Kelvin is this. Its activation energy is given. Calculate a rate constant at 700 Kelvin. Means again we'll use this formula log of K2 log K2 and log of K1 is equal to EA upon 2.303 R, and this is 1 by T1 minus 1 upon T2. So here how to proceed with this? So K1 is given low at lower temperature, rate constant is low. Always remember at low temperature, rate constant will be low, and at higher temperature, rate constant will be higher. So we have the value of a K1. We have the value of K1 which is equal to 1.6 into 10 raised to minus 5 per second. K2, this is what we need to find, right? And R value will take 8.314 joules per Kelvin per mole. T1 is directly given in Kelvin, that is 600 Kelvin, and T2 is what? It is given to be 700 Kelvin, no need of conversion. Activation energy is also given. Everything is given over here, that is 209 kilojoules per mole. We'll take this in joules per mole. So that is 209 into 10 raised to power 3, right? Into 10 raised to power 3 joules per mole. So we'll substitute over here in this formula. So what will come over here is log of K2. We don't know what it is that, but we are told to find for this 1.6 into 10 raised to minus 5. We need to find that K2. EA is given to be 209 into 10 raised to power 3 divided by 2.303. R is 8.314, and this is 1 upon T1 is 600 minus 1 upon 700 Kelvin. So this is log of K2 1.6 into 10 raised to minus 5. How to solve this? Keep this as it is. First we'll find this value. Okay, first we'll find this value. This is 209 into 10 raised to 3. This is 2.303 into 8.314 into 600 into 700. And on the top, it will be 700 minus 600. No, that is what we are going to do over here. That is equal to 100, right? We write it this way: 700 minus 600. This is log of K2. Don't open this bracket as of now. Your calculations will become tougher and tougher if you try to split this term. Uh, this is 209 into 10 raised to 3, and this will become 100, no? And this is 2.303 into 8.314. So this value comes to log of K2 upon 1.6 into 10 raised to minus 5. This value. So this value will find 209 divided by 2.303 divided by 8.314, right? That values comes to be 10.91 into 10 raised to 3 into 100. So this is log of phi is 10.9 into 10 raised to 5. So this will be is equal to something. 10.9 is approximately close to 11, right? 11 into 10 raised to 5. So log of K2 upon 1.6 into 10 raised to minus 5. We'll have to take a antilog both side. Oh, here I think I made a mistake. I did not consider this. These values I did not consider. So just make a correction. This is 600 by 700. That's what I'm thinking. How very high value I was getting. So let's do it from here. So here, yes, no, that is what we did not consider over here. So just make a correction. So I'll write this way: log of K2 upon 1.6 into 10 raised to minus 5 is equal to how much this comes to 209 divided by 2.303 divided by 8.314 divided by 600 divided by 700 and multiplied by 10 raised to 5. So this answer comes to be 2.59. 2.59. This is coming to be 2.59. So if we take antilog on both side, antilog of K2 upon 1.6 into 10, antilog of, I mean, antilog of this log of K2. I want to get rid of this log, no? That's why I'm taking antilog on both sides. 10 raised to minus 5 is equal to antilog of 2.59. So this antilog and log will get cancelled, and what remains is just I'll write this over here. What remains is K2 upon 1.6 into 10 raised to minus 5. You need to find an antilog of 2.5. Say 2.5 means it is 10 raised to 2.59 or 2.6. 10 raised to 2 point. This is what is the meaning of antilog to the base 10, right? Uh, this is 2.6. If you solve this, if you find the logarithm antilog of this using anti-logarithm table, you will get the value to be is equal to 389. You can use the anti-logarithm table over here. Therefore, K2 is what? K2 is 389.04 multiplied by 1.6 into 10 raised to minus 5 multiplied by 1.6. K2 is equal to 622.47 into 10 raised to minus 5. Yes, per uh, second. This will be per second because other one was per second, no? So what is happening? K2 is increasing by so much unit, no? So K2 earlier K2 was K1 was 1.6 into 10 to minus 5. This is 622.47 into 10 to minus 5. Okay, here is the question. What is the order of reaction? What is the unit of rate constant for the second order reaction? This is one question. And second, they have shown a graph, and with respect to that graph also, they have asked a question. First we'll solve this first order reaction. What is the order of the reaction? It is the sum of the powers to which concentration terms are raised, sum of the powers to which concentration terms are raised in a rate law expression. This is what the order of the reaction definition. You will write this way. It is sum of the powers in which some of the powers to which concentration terms are raised to which concentration terms are raised. Some of the powers to which concentration terms are raised in rate law expression. What is the unit of rate constant for the second order? Right? So how do we find that rate unit of the rate constant for a second order? So rate is equal to K, let's say reactant A raised to 3. Sorry. Second order means we'll write raised to 2, no? So unit of the rate is what? Moles per liter per second. K I need to find. Units of the A is what? Concentration. It is moles per liter raised to power 2. Therefore, K will be is equal to what? Units of the K. Moles, moles per liter per second divided by this will become this mole per liter the whole square. Therefore, K is equal to moles per liter per second, and this is mole square per liter square. So this one will get cancelled. This will go on the top and it will become liter. So this is unit will be per mole liter liter means this raised to this is already minus one is there, no? Or I'll show it from here. Don't worry. So this is mole in the numerator, which is having 1. Denominator mole raised to 2. So when I take it in the numerator, it become mole raised to minus 2. This is liter per liter, and this square, which is in the negative sign, it will become 2. And this per second as it is. So 1 minus 2 is minus 1. So per mole, here it is liter and per second. This is the unit of the rate constant. Now coming to this question, solve it here. The graph is given over here. What is the order of the reaction? Okay, like it is written ln of r versus time. So this is very clear from the integrated rate law expression. How the integrated rate law expression we write this way. We write it integrated rate law expression for the time or a rate constant to be this way: 2.303 k log of r0 by r. This is what we know, but how this is derived? Okay, when we do the integrated rate law expression, we get as ln of r is equal to uh, minus kt plus ln of r0. This is what we are getting. Then we convert, we write it in this format. Then we write it in this format, like kt is equal to ln of r0 minus ln of r. Then we write it this way. We just rearrange it. So this kt is equal to what? ln of r0 upon r, right? And this t will be is equal to what? 1 by k ln of r0 by r. To convert logarithm into natural logarithm, we multiply a factor by 2.303. Then we convert this log of r0 by r. We convert it this way. So we are getting it this way. What starting point is this? Starting is this. Graph could be asked based on this equation. So this equation is resembling to that of a straight line, right? Y is equal to mx plus c, right? So what is y over here? ln of r, which is there on a y-axis. Uh, intercept is maximum value of the concentration. This is what the intercept is, maximum value. That is, this is our c. I'll just relate it this way. So this is I'll write with a red pen. This is my y. I'll clean the other things. Just give me a second. Yeah. You can copy this. So this is y over here. This is y. This is mx and this is c. So if you want to write an equation of a straight line, how you are going to write? It is this way, no? If slope is negative, in this case, slope is negative. For the positive slope, you write it this way. And this is what the c is. This is y-axis. This is x-axis. And this is what the slope is. Slope is positive, which is equal to m, right? And for the negative slope, same graph is this way. This is intercept c. This is y-axis. This is x. And this slope is equal to minus m, right? So here this minus kt means what? Minus m. So r is variable, time is variable, k is constant, and c is the intercept. So how you are going to plot this graph? It is this graph, what is shown over here. That is ln of r versus time t is x, and this is a negative slope. So what is the order of the reaction? From the graph only we can figure out, since it is ln or log, it is a first order reaction. This is first order reaction. Okay, write the integrated rate law expression. For this is the integrated rate law expression for this graph. What is the value of x? Means they are asking what is the value of the slope. Slope over here is equal to this, no? So it is minus k. Slope is equal to minus k, right? There is one more possibility. If the same graph is asked in terms of log, means if this is a graph which is asked in terms of log. Let's say log of r versus time. How you are going to solve this? The same equation which is there, you need to convert that to a log. So it is this equation, no? ln of r minus kt plus ln of r0. How you will convert? You will multiply this by 2.303 log of r, which is equal to minus kt plus you will multiply this also 2.303 log of r0. See, I am not multiplying it throughout. I'm just converting ln to log. Divide whole equation by 2.303. What you get is log of r versus minus kt upon 2.303 and plus log of r0. So you will be plotting a graph of this log of r versus time t, right? And a slope is negative. This will be a slope. which will be is equal to this minus, slope will be minus k by 2.303, right? In the case of log, otherwise it is minus k, no? Now it is 2.303, and this is the intercept, which is log of r0, maximum value of the r. So that's it. So here, the question asked is starting from the rate law expression, derive a expression to show that a half-life of a zero-order reaction is directly proportional to the initial concentration of the reactant, inversely proportional to the rate constant of the reaction. So starting from the rate law expression, let's consider a reactant A getting converted to product P. Okay, so how I will write rate is directly proportional to the concentration of A since it is zero order, I rest write zero. So rate is equal to what? Rate is equal to K. Since I am removing this proportionality constant, I am putting that is equal to K, A raised to 0. So rate for this instantaneous rate could be written as this way, no? Minus dA by dt also is equal to dP by dt. So I'm replacing this rate term over here by dA by dt is equal to K. Anything raised to 0 is 1. A raised to 0 is 1. So what I get is dA is equal to minus K dt. So integrating equation 1, let's mark this as a equation 1. Integrating equation 1. So integral of dA is equal to integral of minus K dt. So what I will get over here is that integral of dA will be uh, it will be is equal to A, and here minus k is outside, and it will be integral of just dt. So this A will be is equal to minus k dt will be full time plus integration constant I. This is my equation 1. So I need to find this I value. So to find I, that is integration constant. So time at time t is equal to 0, what is r is equal to or a is equal to? See, in many books, it is given r. Okay, don't get confused. I have started with the a as a reactant. You can start with the r also. Okay, accordingly, this thing is going to change. So a is equal to what? At time t is equal to 0, concentration of a is equal to a naught. So here, substituting that in equation 2, what I get is a I write is equal to a naught minus k into time is 0, right? Plus I. Therefore, I is equal to R naught, the integration constant. Substituting I is equal to R naught in equation 2. What I get is A is equal to minus KT plus uh, A naught. Sorry. This is A naught. See, I am also getting confused. This is A. So here it is A naught. So this is my integrated rate law expression for the zero order, right? Now for the half-life, they have asked for the half-life. So half-life is what? At T half, what happens? R is equal to half of this, or A is equal to concentration of the reactant A will be is equal to this A naught by 2. So I'll write this. Uh, A will be is equal to A naught by 2. I'm substituting in this equation, which is equal to minus KT plus A naught. So therefore, KT is equal to what? A naught minus A naught by 2. So KT is equal to half times A naught. So this T is equal to what? T will be is equal to, that is equal to T half, no? I should say this is to be T half. So T half is equal to A naught upon 2K. So that's what proved, that it is directly proportional to initial concentration. A naught is directly proportional to initial concentration and inversely proportional to the rate constant. This is a rate constant. It is inversely proportional. So this is something. Okay, it's not coming in the, yeah. This is what was expected. This equation. This question could be asked for 3 marks also if you are doing so long derivation. Okay, this is the last question of this session, so on this chapter. So this is a question asked is on increasing the temperature of the species by 10 degree, the rate of reaction almost double. Most appropriate reason for this. Um, okay, so what is the meaning of reaction? What is the meaning of reaction? Like there are particles inside a chamber. Let's say this is a particle inside the chamber. Uh, Chamber means one container. Uh, they are into continuously random motion, right? They are continuously moving, isn't it? This is a chamber in which it is continuously in a random motion. So why reaction happens in the molecule? It is because of the collision. These particles are colliding. That's why the reaction happens. Like you can take example like Janna, like you are walking in a corridor. Okay, someone collides you, someone hits you by mistake, purposely. You tend to show reaction, right? You tend to show reaction. Same way, when particles collide, the reaction will be taking place. Okay, and the other factor which defines is that collision. All the collision doesn't lead to reaction. Means collision should have a enough amount of the energy and it should have a proper direction. आम्ही जात्रेक वयता तेन्ना गर्दी असता गर्देन आम्ही खूप जाणांक पडटा but we don't sit there giving reaction to each and every person, right? आम्ही कोणाक रिएक्शन दीत रावना की ते कोलिजन इतके इंटेन्सिटी आसना पण जात्रेन सुद्दां तुका कोणी बरे हार्ड हिट केलो, you will tend to show reaction. You will ask, what is this nonsense, right? So although collision doesn't lead to reaction, collision is important for the reaction, right? And it should have a proper intensity. So whenever we supply a temperature, means when we supply a heat, what happens? Entropy, the degree of randomness increases. And these particles tend to move with a higher speed and collision increases. So with increase in temperature, what happens is that collision frequency is increasing, and that's why this is the appropriate answer. And that's why the rate of the reaction is almost double. Thank you so much. I am ending this chapter over here. See you in the next class.